We saw how typecasting works in C++, and it's essentially the same as in Java. There are some minor differences. For example, we can use this safe way of casting things into different type using static cast. There are some other things like this, dynamic cast, as you might expect. Since there's a static, it's probably dynamic. And there are two more, and the differences between this kind of casting and the old style C casting, which is parentheses, saying double in parentheses, which we use in Java, is that this is considered safer, so that you get more compiler warnings, compiler errors if you try to do something unsafe using those open close parentheses, that kind of casting. Okay, so the whole reason for casting is you want to change types of variables or expressions. So if you had a literal constant, like let's say 2, if you had a literal constant 2, that would be taken as an int 2 in Java and in C++. But if we add a if we add a 0.0 to make it 2.0 in Java, that's considered a double by default. And it's the same situation in C++. A 2.0 would be considered a floating point number, double precision floating point number. And we use this to force precision arithmetic so that we can take the average of two numbers and not lose the fractional part. But what about variables? We can't just tack on a 0.0 to the name of a variable. Instead, we have to cast, and we saw we can use static cast and the old C style casting. As much as possible, you always want to explicitly cast or convert things if you want to change the type. There is some implicit or automatic casting. In Java, it was always promotion. In C++, this is the problem is that you can, under some cases, the automatic or implicit casting can be demotion. So for example, if you say int x is equal to 2.5, that 2.5 will be demoted to a 2 and stored in that int. So that does not happen in Java. In C++ it can. Most of the time we rely on implicit typecasting to do stuff like this. When we say 17 divided by 5.5, we assume that the 17 is going to get casted automatically into a double precision 17.0. So in C++, more than in Java, it is always better to explicitly say what type of conversion you're doing. So by doing things like, you can use the old C style parentheses operator to cast. This is what we used in Java. Java, the situation was a little different in that we were all pretty much always safe. In C++, because we can do unsafe things, it's actually better rather than using this. Let me just backtrack. For simple primitive data types like 17, it doesn't matter whether you use open close parentheses double or if you use static cast double. That said, as much as possible, try to use static cast. Later on, we will see that when we have classes and inheritance, in those situations, we might have to do static cast, we might have to do a dynamic cast, and a bunch of other casts. So, sure, there are situations where you use other things, but for now, the rule of thumb would be use this as that is static cast and then type as much as possible. Try to get used to it and not use the old C style casting. Just, it's a good exercise. Okay, let's move on to post increment and pre-increment. Now this works exactly like in Java, but I'll review it very briefly here. So this is just shorthand notation, that is, it allows you to write very succinct code rather than saying, say, some int variable I is equal to I plus 1, you can just say I plus plus. lot of programmers like this. Or if you want to decrement, rather than saying I is equal to I minus 1, you say I minus minus, or in this case, int var minus minus. These things are completely equivalent. Now the place where we have to be worried is if we have pre-increment or post-increment inside an expression, or on the right-hand side of an assignment statement. We do have to worry about exactly how this works, and it works the same way in Java. So if you're used to this in Java, all of this will just be repetition of what you learned before. So you can do, let's take a look at the difference. So the difference would be difference between post-increment and pre-increment. Now the way the book describes it, it says if you do post-increment, you can read this as use the current value of the variable, in this case I, then increment it. Excuse me. Whereas for pre-increment, you read this as you increment the variable first, then use the new value. And this is perfectly fine. That's the way to think about it. Now I think about it just a tiny bit differently, in that when I see something like this, I++, I think, okay, I is going to be incremented just like ++I. I is going to be incremented after this is done. However, I think of this whole thing, I++, as one sub-expression. The value of that sub-expression is the old value of I. That's equivalent to what the author uses. I just think about it a tiny bit differently, and they're both the same. And whereas if you have something like ++I, the value of this sub-expression, ++I, is the new value of I, that is after incrementing. In both cases, I does get incremented. It's just that what is the value of this in a sub-expression, as a sub-expression. Okay. So where the text says then use the new value, this use is defined as whatever context the variable is currently in, that is whatever sub-expression. If you use it as a separate statement like I++, semicolon, like this, or ++I, semicolon, there is absolutely no difference. These two things give you the identical result. Later on, so the place where this will become important, if there's one thing that I would say, one tiny thing that is different about this, is that this pre-increment is considered a little bit more efficient. The reason for that you can understand when you think of this plus I++, you actually have memory set aside for I, and you also have memory set aside for this sub-expression. So if you're never going to use the old value of I before the increment, then this is a little bit more efficient, because when you do ++I, you don't set aside extra space for the sub-expression. And so this is very tiny. It's a very tiny difference. It's just one int extra that you use if you use I++. Not a big deal, but here's the thing. Later on, we'll get to iterators. Iterators are a way of navigating through data structures. And there, you can also, it turns out, use ++ iterator or iterator ++. And there, the iterators might be, essentially, it's going to be like an object. And there, if you use I++, it actually, you have a duplicate object, which is the old value of this iterator, assuming it's an iterator. And ++ iterator, you don't have that duplicate object, so this is quite a bit more efficient. Especially if you have this in a loop, you don't have these objects popping up all over the place if you use post-increment. And whereas pre-increment, it's that much more efficient. So that's really the only difference between these two, if you use them separately. That is, if you use them like this, as a separate statement. Of course, when you use them in a sub-expression, it is critical, which one you use. So, for example, if n is 2 and you say value produced is equal to 2 times n is incremented to 3, but you get the old value of n, which is 2. 2 times 2 is 4. So if you print it out, you'll get value produced as 4. It should make sense, even though n is 3. Okay, so after these two statements are executed, n is 3, value produced is 4. If you had used a plus plus here, it would be different in that value produced would be 6. So switch this n plus plus to a plus plus n, you get a 6 over here. So it's pretty different. And this is because of pre-increment. Same rules as in Java. So if you're used to this in Java, no difference. The only difference would be that later on we will see that we can use this operator in the context of iterators, which we cannot do in Java. Okay, console input and output we've been doing for a while, so let's quickly review this. You can do I/O with these two objects, console in, console out. Later on we'll use file in and file out. There is no such built-in thing. This is just like system.in, and this is just like system.out. These are defined in the C++ library called IO stream. And so to use cin and cout, you have to have these two lines. It turns out the second line is not crucial, but it makes your code a little bit easier to read, in that this st standard namespace is always attached to all the names. Okay, so we'll get to namespaces soon. So these two lines tells the C++, the compiler, to use the appropriate library so that you can use cin, cout, and cerr. Just like in Java, we have system.in, system.out, and system.err. Same idea. What can you output? Variables, constants, literals, expressions, and we saw all of these in the previous examples. So you can say cout, the number of games, which is, let's say, is an int, and then a string. And so two things are outputted. That is the value of this variable, number of games, which is probably just an int, and then the value of this string, this literal string constant. And this is called cascading. We put out multiple values in one cout. Rather than using system.out.println in parentheses, this thing plus a string, you use the insertion operator and cascade or daisy chain these insertion operators. You can use the \n for a new line, or you can use this end line object. And we've seen both in examples. So these two are completely equivalent. You can use the \n inside a string, or you can use cascade an end line object, get the same result. You can format, for example, if you want two digits after the decimal point, we have to explicitly tell how to format. And we saw this with printfs, which actually came from C and is available in C++, but if you're using streams, you want to use this formatting methods, formatting functions. So what we can do is we can say, okay, I want to use fixed point, and say I want to show the decimal point, and I want 2 digits after the decimal point every time. Even if it's 78.00, it'll print out the fixed decimal points, that is fixed number of digits after the decimal point. Show the point, that is make sure even if there's no fractional part, show the decimal point, and always show 2 things after the decimal point. Okay, so once you put these statements in, you get things like, if you say print out the price and it's a floating point number, you will always see 2 decimal points. This is useful for when you have currency, things like that. And you can modify all of these. You can modify this to any number. Okay, and next up we'll take a look at cerr. Cerr is basically the same as cout, and it just prints to a different stream, although it does appear in the same console output as cout.